Okay, welcome back. In this second program, part 2, we're going to be looking at the idea of voltage. Okay, so in order to help explain the idea of voltage, what I have here is a diagram of a battery. There's our battery, and it's connected to a circuit, part of a circuit here. So we've got a piece of wire making contact with this end of the battery, and a piece of wire making contact with the other end of the battery, and you can imagine that wire then goes off and completes the circuit. It might go to a globe or some other electrical device. Now you may already know that the end of the battery with that little bump on it, that's the positive end of the battery, and the end with the dent is the negative end. Now we often represent batteries in electrical circuits as a series of short and long lines. So for example, we could represent a battery in a circuit with that symbol there. The long end of the battery is always a positive end, and the short line is the negative side of the battery. So that's the symbol for a battery. Now in this case, it's a 9-volt battery. Now we'll talk about what that means in a sec. Now the other thing I want to talk about are these little dots here. Each of these represents a coulomb of electrons. So that's not one electron, that is one coulomb of electrons. Now from our previous video you will remember that that means that that little package represents 6.25 times 10 to the power of 18 electrons. So that's 1 coulomb of electrons. Okay, now because this is the negative end of the battery and this is the positive end, then the electrons are going to be repelled from the negative end and they're going to be attracted to the positive end. So the direction the electrons are going to flow is in that direction. They'll go around the circuit and they'll re-enter over here. So that's the direction of electron flow. Of course, the direction of current will be the opposite direction. So that is the direction of current. Okay, so what do we mean by voltage? Well, voltage is a measure of the amount of energy it gives to each coulomb of electrons or charge as it enters the battery. So as these electrons here return from their little journey around the circuit, and I'll change that colour because that's a bit dark. As these electrons return, they're actually depleted of energy. They have no energy left. And when they enter the battery, what is going on inside a chemical cell is a chemical reaction. And that chemical reaction converts chemical energy into electrical energy. Now the details of the chemical reaction is something you would learn in Year 11 chemistry. But we don't need to actually talk about the chemical aspects of what's going inside the battery. All we need to be aware of is that the result of this chemical reaction is that these electrons, as they pass through the battery, gain energy. And in fact, if this is a 9-volt battery, what that means is that each coulomb of electrons as it enters the battery will gain 9 joules of energy as it passes through. So in other words, voltage, when we're talking about a battery or a power source, voltage is the amount of energy given to each coulomb of charge. So in this case, we're talking about coulombs of electrons entering our battery, and it's a 9-volt battery. So that means that in this case, each coulomb of electrons, each coulomb will receive 9 joules of energy. If this was a 12-volt battery, then each of these coulombs, as they enter the battery, would receive or be energized with 12 joules of energy. If it was a 24-volt battery, each of these coulombs of electrons, as they pass through the battery, would be energized with 24 joules of energy. So in this case, these electrons here, as they come out of the battery, they now have been energized and they're flowing on their way to carry that energy to some other part of the circuit. So each of those coulombs of electrons contains 9 joules of energy. Each of them has 9 joules. These ones here that have returned actually have 0 joules because they've spent their energy. And that's one of the golden rules of electric circuits. Whenever charge returns to the battery to be recharged, it will always have 0 joules of energy left. So it must spend all of its energy as it flows around the circuit. So no matter how much energy it's given, it must spend it all as it goes around the circuit. Think of it like this. Think of it that this little battery is your mum or dad giving you some pocket money to go and spend at Luna Park. And the condition is, whatever money they give you, you've got to spend it all at Luna Park. So if they gave you $50, as you walk into the gate with $50, you have to spend that whole $50 by the time you leave the park. So that's a sort of a very simple analogy. So to sum up then, we can say that voltage, which is a measure of the amount of energy given to each coulomb, is therefore equal to the number of joules per coulomb. So 1 volt equals 1 joule of energy given to each coulomb of charge as it passes through the battery. The other side of the coin, there's a couple more aspects of voltage we're going to talk about. This is from the battery point of view. So I'm now going to clear this and we'll talk about what happens when, say, these electrons reach something like a light globe. So we'll clear that. So let's now imagine that we've got a light globe. And there's our wire coming in. And there's our wire going back to the battery. And we'll go back to yellow for our electrons. We'll try to. Light green we'll have to do. Okay, so here's our electrons coming from the battery. Now remember, it was coming from a 9-volt battery. So each of those, sorry, they're not electrons, I beg your pardon, each of those is a coulomb of electrons. So each of those coulombs of electrons is carrying with it 9 joules of energy. So, as these coulombs of electrons reach the globe, they will flow up through the filament, and that electrical energy, as it passes through the nichrome filament, the electrical energy that's stored in the electron gets converted into heat and light. To the point where as the electrons emerge from the globe and come out the other side, if this is the only globe in the circuit and now the next stop is going back to the battery, these electrons would now have 0 joules of energy. So if we were to measure the amount of energy in that coulomb of electrons in there, it would have 0 joules, as would this one. So what's happened is that each of these joules of electrons have given up their energy to the light globe and they emerge out the other side to return to the battery with no energy left, and then they get recharged and get recirculated around the circuit. And that is how energy is transmitted to the circuit. So what electricity is all about really is transferring energy. The electrons aren't consumed, they're not used up in an electric circuit. They are simply transporting energy from the battery to the globe. So that in the battery, chemical energy is being changed into electrical energy. The electrons carry that energy to something like a light globe, and here that electrical energy is then converted into other forms of energy, in this case light and heat. The electrons then return in the circuit back to the battery to collect more electrical energy. And that's why it's called an electrical circuit, because they flow in a circuit. Okay, so in this case then, we could say that this globe is consuming, for each coulomb that passes through it, it's consuming 9 joules of energy. Now, the other thing I want to talk about is the idea of potential difference. Now, potential difference is very similar to voltage, except for one important point. If I measured, actually we'll talk about potential difference and voltage. If I was to measure the amount of energy in that coulomb right there, I would get an answer of 9 joules. 9 joules of energy are in that coulomb. If I was to measure the energy in that coulomb there, my answer would be 0 joules. And so at that point in the circuit, or at that point in the circuit, or even at this point in the circuit, or at that point in the circuit, or even at that point in the circuit, I could say the amount of energy per coulomb over here would be 9 joules per coulomb would be there. So the voltage of the circuit at that point would be 9 volts. Here it would be 9 volts. Here would also be 9 volts. Over here, in this part of the circuit, as the electrons flow through, if I was to measure the energy of any of those coulombs as they pass through at this point in the circuit, I would read that there is no energy in any of the coulombs as they flow through. So at this point in the circuit, the voltage would be 0 volts. Here it would also be 0 volts. So we're measuring the voltage at different points of the circuit. Potential difference is a little bit different. Potential difference is if I am measuring the difference between two different positions. So for example, if I was to measure the voltage at this point and the voltage at this point, and I was to connect it up to a voltmeter that measures potential difference, that's the symbol for a voltmeter, and it measures the difference in the voltage between 2 points. Well, if it's 9 volts there and it's 9 volts there, then the difference is 0. So this would read 0 volts because it's actually looking for the difference in potential or difference in voltage between 2 points. Likewise, if I took my voltmeter over here and measured the difference in voltage between those 2 points, I would also get a reading of 0 volts because it's 0 volts here and it's 0 volts here, so the difference is 0. On the other hand, if I was to measure between that point and that point, because I know that coulombs going into the globe have 9 volts and the coulombs coming out have 0, then the difference will be 9 volts. So here, the potential difference would equal 9 volts. So the subtle difference between potential difference and voltage is the potential difference. You are comparing two different points. Comparing the voltage at two different points. Whereas voltage is just a measure of the energy per coulomb at any given point. Both of these are measured in volts, okay? Either we measure potential difference in volts and we measure voltage, obviously, in volts. So that is the end of our lesson on voltage. The final lesson in our first sequence of programs will be on resistance. Thank you.